In this video, we will discuss about base width modulation, or it is also known as early effect. Base width modulation or early effect. Or it is also known as early effect. Now we will see what is meant by this base width modulation or early effect. In the transistor we have three terminals. What are the three terminals? Emitter, base, collector. Emitter, base, collector. This is the collector. Okay. Now this is base and this one is emitter, this one is collector. The width of the base is very small compared to the emitter and collector. The width of the collector is large. And let us say it is Pnp transistor. Means what? Emitter is heavily doped. P plus means emitter is heavily doped. N minus means base is lightly doped. Collector is moderately doped. We know that in the active region of the transistor, this junction means emitter junction is forward biased. Emitter junction is forward biased, and this junction, collector junction, in between collector and base, we have junction that is called as collector junction. It is reverse bias. Reverse bias means what? This N type is connected to the positive terminal of the battery, and P type is connected to the This P type is connected to the negative terminal of the battery. As it is reverse bias, depletion region is formed in the collector junction, at the collector junction. So, depletion region will be formed like this on either sides of the junction. That means on base side and on the collector side also we have the formation of depletion region like this. If this VCB increases, what happens? The width of the depletion region also increases. Width of depletion region also increases. As width of the depletion region increases, this effective base width, we can say here WB is the effective base width. Actually, from this point to this point, we have the width of the base. As this VCB increases, effective base width decreases. Means if VCB increases, depletion region increases, width of the depletion region increases. It leads to what? Effective base width decreases. By changing this VCB, we can change the base width, effective base width. So that's why it is called as the base width modulation, or it is also known as the early effect. By changing this voltage, we can change the width of the base. That's why it is known as the base width modulation, or else it is also known as the early effect. Why it is known as early effect? Actually, if this junction is forward biased, means what? P type is connected to the positive terminal and N type is connected to the negative terminal. In that case, holes injected into this base region, and after injecting into this base region, these charge carriers can reach the collector region with the help of the built-in potential. Our field is induced here. With the help of that field, these charge carriers can sweep out into this collector region. In the previous case, if this one is reverse biased, okay, that means if this one is smaller, in that case we have width is like this. If this one increases, this depletion region penetrates into the base side. Why this depletion region more penetrates into the base region? Because depletion base is lightly doped. As base is lightly doped, it can penetrate. That means depletion region can penetrate onto the base side compared to the collector, because collector is somewhat better in case of the doping when compared to the base. So that's why depletion region is more penetrating on this side like this. If you increase this one, so this depletion region can increase like this. That means effective base width decreases. That's why it is known as the base width modulation. As this one, that means if width of the depletion region increases, effective base width decreases, then the charge carriers can reach this collector region early when compared to the smaller values of VCB. That's why it is known as the early effect. We have three consequences of the early effect. First one is increase in alpha. Second one is increase in IPE, that leads to increase in current through the emitter junction. And third one is reach through or punch through. Now we will see first one. Alpha increases due to the base width modulation or due to the early effect. Now, if this depletion region, width of the depletion region increases, means effective base width decreases. As effective base width decreases, number of recombinations decreases. As the number of recombination decreases, we know the alpha equal to what? IC by IB, or else alpha equal to IPC by IB. Alpha equal to IC by IB. Actually, alpha we can write alpha equal to IC by IB. So that means as number of recombinations decreases, IB decreases, means recombination current decreases. As this one decreases, alpha increases. Or else we can say in another way like this also. If recombinations decreases, transport factor, that is beta star, increases. Why? If recombinations decreases, IPC increases. As IPC increases, beta star increases. As beta star increases, alpha increases. Since alpha equal to what? Beta star into gamma. Already we discussed about this one. Now let us see second one. So this is the first consequence. What about the second one? This IPE increases. We know that IPE equal to what? IPE is directly proportional to dP by dx. That means what? Current is a direct diffusion current. IPE means what? Injected current of the poles, means these carriers can be injected due to the diffusion. Diffusion current is directly proportional to the gradient of the charge concentration. Means here, if this one is dx means what? That is the x means width of this base. As VCB increases, effective base width decreases, means this one decreases. As this one decreases, IPE increases. From this equation we can say IPE increases. It leads to what? Increment in the IE. That means due to the base width modulation, current through the emitter junction increases. In this case, we can call these junctions, that is collector junction and emitter junction, are known as interactive junctions. Why these are called as interactive junctions? By changing voltage at this junction, means by changing voltage at the collector junction, we can change the current at other junctions. So that's why these junctions are called as the interactive junctions. And last one is called as the reach through or punch through. Here what I said, base width modulation means what? If VCB increases, effective base width decreases. At the particular value of VCB, let us say for large value of VCB, this effective base width becomes 0. As this one becomes 0, this collector junction can reach the emitter junction, or else this collector can reach the emitter. That means this phenomena is known as the reach through. Here collector is reaching the emitter. That phenomena is known as reach through concept, or else punch through concept. After reaching this emitter here, we can say this collector and emitter are electrically shorted. As these are electrically shorted, this large reverse bias voltage will appear at this emitter region. As this large voltage is appeared, means this one is negative and this is positive, this negative terminal here. That means here we have more negative voltage. This more negative voltage can attract more number of volts from the emitter region. As this is attracting the more number of volts, then current in the collector region increases. Current in the collector region increases. As this current increases, means current in the collector increases, power dissipation in this region increases. As power dissipation in this region increases, means if this dissipated power may exceed rating of the transistor. If this dissipated power exceeding the rating of the transistor, it leads to the damage of the transistor. So that's why it is undesirable thing, reach through or punch through. Okay, so what are the consequences of the base width modulation? First one is increasing alpha. How alpha will be increased? How alpha will be increased? Base width modulation means effective base width decreases for the increment in the reverse bias voltage. As effective base width decreases, recombinations of electrons and holes in the base region decreases. As that one decreases, transport factor increases, beta star increases. As beta star increases, it leads to increment in the alpha. That is the first consequence. And what about the second consequence? We know that diffusion current, that is diffusion current, IPE is directly, that means volts are diffused from emitter to the base region, that is IPE equal to dP by dx. Due to the base width modulation, this effective base width or else this width decreases. As this distance decreases, IPA increases. As IPA increases, we can say that what? Current in the emitter junction increases. Current in this emitter junction can be increased by varying this VCB. That's why these junctions, collector and emitter junctions, are also known as the interactive junctions. Why these are called as interactive junctions? Since by varying voltage at this junction, collector junction, we can vary the current at another junction, that is emitter junction. That's why they are called as the interactive junction. And last one is what? Reach through or punch through. Means if VCB is large, for the larger value of VCB, effective base width becomes 0. In that case, this collector and emitter electrically short circuited. In that case, this large voltage will appear at the emitter. In that case, we will get more number of volts into the collector. It leads to the more current in the collector region. As that current is more, we will get the more dissipated power in the collector region. If this dissipated power exceeding the rating of the transistor, power rating of the transistor, that leads to the damage of the transistor. This is all about the base width modulation and its consequences. We will meet in next class.